Hello, everyone. This is Brad DeFries, Program Coordinator at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Asset Management, Tips and Tricks. This session is one of several webinars conducted by the Environmental Finance Center Network for the Smart Management of Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local water systems achieve and maintain compliance with the Safe Drinking Water Act. Workshops, trainings, and direct assistance are provided on asset management, water loss reduction, water system collaboration, fiscal planning and rate setting, energy management, funding coordination, and managerial and financial leadership. I will be providing some technical support for today's session. Please take a moment to observe your GoToWebinar control panel. Most of the functions are self-explanatory, but I'd like to draw your attention to the questions section on your control panel. During today's session, you will all be kept on mute to ensure audio quality and minimize background noise. Should you have a question, please type it into the GoToWebinar question dialog box. We will be holding all questions until the end of today's presentation to ensure that we end on time. We have over 200 registrants for today's webinar, and we will try to get to as many questions as we can. Today's presenters have consented to share their presentation slides with you, and we will make the slides available as well as a video recording following the webinar on the EFCN website, efcnetwork.org. Please allow 1 week for the processing and posting of these materials. We will also be showing 2 videos during today's webinar, which will be made available as well. Now I'm going to take a roll call with all of our panelists to ensure everyone's audio is working properly. Heather, are you there?
Yes, I am.
Dawn, are you there?
Yes, I am.
And Jeff?
Yeah, this is Jeff.
And Kevin?
Yes, here.
And Paul?
Yep, Paul's here.
All right, great. Our audio is working nicely. I'm now going to hand it over to Heather Himmelberger, Director at the Southwest Environmental Finance Center at the University of New Mexico for introduction.
Good morning or afternoon, everyone. Thank you so much for joining us today. I'm really glad that you're able to be with us. We are here with 3 of my favorite folks in asset management, and I think you're going to learn a lot from them because they've been out practicing in asset management for quite a while. Jeff Layton has done a fabulous job at the Portland Water Bureau in asset management, and he's also a leader nationally with the AWWA Asset Management Committee. So he's got both a local and a national perspective in asset management. Kevin Campanella had worked for Columbus Water for a long time and is really very well recognized in asset management, and now has gone to private consulting and has continued his asset management expertise. And he's been a star of our asset management manual, AM Can Work, so you may have seen his videos, particularly in the area of level of service, where they did some really excellent things in Columbus. And then Paul Crocker, who works for the Kansas City Board of Public Utilities, has done amazing things in maintenance and has really taken that organization to a new level in looking at maintenance and why they do the things they do, and has come up with some great cost-saving measures. So I'm really glad that the 3 of them have consented to be with you today, and I think you're going to learn a lot from their experiences and the tips and tricks that they came up with. So with that, I'm going to turn it over to Dawn and let her do a more formal introduction and lead the rest of our event today. So again, thank you all for being here, and thanks to EPA for funding this webinar.
Right, thank you, Heather. So first up today, we're going to have Jeff Layton, and he is going to be speaking to you a little bit about his experiences and some tips and tricks. Jeff is the asset manager for the Portland Water Bureau. He's also the chair of the AWWA Asset Management Committee and has served on 20 committees on infrastructure for the Water Research Foundation. So bear with me for just a second. I'm going to pull up his slides and turn it over to him.
Thank you. Hopefully everyone can see the first slide. Yes, I am Jeff Layton. These are my tips for asset management. I don't know if there's some tricks in there or not, but I'll focus on the tip piece. So I do work for a large utility, the Portland Water Bureau, and I have staff dedicated to asset management. But many of you are in smaller utilities, but I think you can still take important steps forward in asset management without a lot of staff, and I hope to give some examples of things you can do. And as you heard, I am chair of this committee. So AWWA has a lot of materials on asset management. On the asset management resource page is what it's called. So if you typed in asset management resource page on the AWWA website, you'd find a lot of asset management materials. So my first tip is, when it comes to asset management, the best thing to do is to do something. There are a lot of activities that I would call asset management. Everybody has their own opinion about what asset management is. So we asked members of our committee what activities that we call asset management that are the most important or the best opportunities for people to progress. So here's a list of those. The first bullet, set service levels and monitor. That's goals for the organization. So set some goals and then track how well you do. Next, manage risks of asset failure. And you'll hear some more about the approach that we've taken here. Assess the condition of assets, probably in this case, at least the most important assets that you have. Next one, make good investment decisions. Consider all costs and benefits. You'll hear a little bit more about that, not just the initial capital costs when you're comparing alternatives, but the total life cycle costs. And then you'll hear some things about not just costs to the utility, but think about your customers or society. And next and last on the list here is estimate the remaining life of the assets. So these are the things that we identified in our committee as being really important things and really valuable opportunities for advancing in asset management. I'm going to focus on the service levels and the risk piece. So I think it's important to have performance goals or service level targets. If you can, make them simple. Something that the public or your board can understand, something that you can actually measure. And of course, something that's important to what you do. So the way I look at it, the results of doing this, establishing and then monitoring service levels, can either be used to support your claim that you're doing well, or the results can form a basis for requesting more funds or more staff to do better. So this is a screenshot from a dashboard that the city of Portland has. The public can see how all the different parts of the city are doing. These happen to be from the Portland Water Bureau. We have a large number of service level targets that we use internally, but these are the big 6 for our water utility that the public can see. So the first one, which I'll talk some more about, focuses on outages. Then the next one is one we have about call holding time. Then there's one about maintaining our high bond rating. And then there's 2 on regulations. One's water quality regulations and one's environmental regulations. And then the last one is something near to my heart about asset management, about risk management. So these are the 6 that we're using that we show to the public that indicate the performance of our utility. So again, what's more important, say, than meeting regulations or ensuring that there's a limited number of outages? So I have a little story here about our outage service level. When we first created a service level, we looked around to see what others were using and ended up with the one that's listed here as the first bullet. No more than 5% of customers are out of water for more than 8 hours a year. It's what we saw a lot of people using, something similar. But it became clear that it was not clear to a lot of people. 5% of this and 8 hours of that, it was very confusing to a lot of people. And for us to figure out if we were meeting this goal, we needed to track every outage we had, whether it was planned or unplanned, and who was affected by it and for how long. And it was just a lot of effort for us to get the data. It involved our dispatcher, talking to the people in the field, back to the dispatcher, to our planner scheduler, and in the GIS. We were having a hard time tracking the data, and when we did, we still had this situation where people weren't understanding it. So what people do understand, we've come to accept, is that if you give them an advance notice, a planned outage is much easier for them to deal with than an unplanned one. So we want to focus on the unplanned events. And people also want to be limited in the period of time in which they're out of water. 8 hours for us seemed like a real limit. So we created this service level on outages that's represented by the second bullet here. No more than 2 unplanned events in a year where customers are out of water for more than 8 hours. That's what we've been using. It's easy for us to measure. The crews know exactly what's expected of them. Do everything you can to keep an outage below 8 hours. And that has become our main outage target. Okay, the next topic I wanted to cover was about risk. If you remember back to that dashboard, there were 6 service levels, and one of those was to address our risks. And I'm really proud of the fact that our utility has put a lot of emphasis on risk management. My tip is know what your risks are, document them, and it may surprise you or it may confirm what you know. Probably some of both as to what your risks are. We had a few surprises and I'll share that with you. Remember that risk is the likelihood of failure and the consequence of failure. Some of us multiply those together to get risk, others of us combine it in different ways, but it is represented by both of those factors. So, first question, which of these 2 assets is the high risk? The pipe on the left is older, and it's more than 4 times the diameter of the pipe on the right. Does that make it a higher risk? Just because it's older does not make it more likely to fail. And just because it's a bigger pipe, at least on my screen we've lost the...
Yeah, we have. I'm not sure why. So
okay.
Just 1 second, and
okay.
I'll turn it back over to you. I don't really know what happened. I apologize.
Unless you want to do a Google search. Oh, there we go. Much better. Okay. And just because it's a bigger pipe doesn't mean it has a higher consequence. So that pipe on the left, it's important, but it's one of our 3 parallel supply lines. So if it fails, we do have other ways to get water to town. And if it fails, it's going to fill the forest with water. Not much of a consequence. The pipe on the right is hanging from a bridge over a railroad line. The side slope of the ravine, which you might be able to see in the distance, erodes very easily. We have a pipe on the far side of this bridge. It failed in 1985. It undermined the foundation of the bridge, and it took the road and the bridge out of service for 6 months. We covered the rail line in sand for a week. So we estimated the impact of all these elements and the failure at $5 million. So back to one of those earlier comments about, the total costs represent costs to us, costs in lost business to the railroad, and cost in lost time to people who were delayed in traffic because they couldn't cross over on this bridge and had to go a different route. It's very slow to respond. Okay. All right. Let's try that question again. Which is the high risk? Well, it's a trick question. They both were. The tank on the left is a key storage facility high on a hill serving a local area. The old tank might fail. So what we've done is we've taken steps to connect to adjacent pressure zones so that water can still be provided even without the tank. So while we haven't changed the likelihood of failure, we certainly changed the consequence. So it was a high risk, but not anymore. The piece of equipment on the right is one of those surprises that we found. It's our bill printing device. When we first looked at all the risks in our system in 2007, few in our organization had ever heard of it. Well, actually, few still have ever heard of it, but they really should be aware of it because it's pretty important. If we can't print bills, then we have trouble with revenue. We had no backup system for this. Once we realized the risk of this part of our business, the part that brings in money, we took steps to mitigate this high risk by arranging for alternate printing options with other organizations. So, that's part of the surprise. What are your risks and how are you going to deal with them? And it's not necessarily just delivering water to be an important risk. Okay, next up about fall hazards, which certainly we've got a lot of our risks that are captured in this category. Fall hazards can be consequential to employees, as the example on the left, or to the public. Ladders into vaults and up tanks in poor condition can be high risks, but they are relatively cheap to fix. It's some of the easiest risks we have to address. Not all fall hazards, though, are easy to mitigate. We supply water to a decorative fountain, shown here on the right. We own the fountain. It's a work of art. We can't just prevent people from turning this decorative fountain into an interactive fountain. We posted signs not to go in, and we certainly don't encourage people to stand on a ledge in this fountain like you can see, but it happens. They do it. So this is another one of those surprisingly high risks that we have. Okay, another tip for you: if you don't look, you won't know until it fails. And some things are hard to look at. It's very expensive for us to inspect buried pipes, but not all assets fall in that category. Many of them do not. If it is buried pipe, in that case, we need to be very selective about which ones we're going to assess. But in this case, pipes hanging off bridges, the example on the left, or pipes installed inside a bridge deck, the one on the right, are relatively inexpensive to inspect. So go out and inspect them. They're potentially high consequence. The pipe on the left was badly out of alignment, and it was over one of our major highways. It was relatively easy to fix. The pipe on the right is obviously showing signs of corrosion. So these are assets that could fail soon, and like I said, are relatively easy to deal with. So go out there and do it. Not sure why the mouse is it's not responding to my mouse very quickly. That's the delay. Okay, so next one. Common storyline is we collect too much data, but not the right data. And maybe that's true in some cases. So what I'm saying here is collect data that you know you can use and that you need. And this is an example where we're tracking data on the failure mode of our pipes. The reason is, if we know how our pipes fail, then we can figure out what we can do to avoid failure or limit the impacts. And obviously that would be good. That's a good reason for collecting data. So our field crews now have had the ability to record information in the field in the last 4 years. And this table of information reflects the results of that. The majority of our smaller cast iron pipes, so that's the first row of data there, you can see the majority fail by vertical breaks. That's the nature of our system. There's not much you can do to assess the condition of a pipe to know about a vertical break before it happens. So if one of those pipes has a potential high consequence of failure, what we do is we don't do condition assessment, we prioritize valve exercising to reduce the consequence. The bigger pipes, you go down the figure here, you'll see as you get larger diameter, there's more seal failures for us. Small leaks associated with those failures can turn into big leaks and pipe breaks. So we can direct resources towards leak detection on our large cast iron pipes, for example. Our steel pipes are failing by corrosion. We can listen for leaks on those pipes, or if the pipe's really important, we can measure remaining wall thickness. The point here is that the data the crews are collecting is helping us figure out what to do. To me, that's the right data. I wanted to point out there's a category there, other. We've been doing a much better job over time in the field of collecting results, meaningful results about the failure mode, but we still have a ways to go. And because this reflects 4 years of data, the amount of times that the field crew's not giving us a failure mode has been decreasing over time. But we still have work to do, and we continue to improve on our data collection. And again, we share this information with the field crews so that we make sure that it's consistent with their interpretation of what kinds of failures we're having, and so they can see we're using it, and so they understand that we still have some improvements in data collection. And then my last slide. Don't think you can't make a good decision without a lot of data. Obviously, it's good to have data, but not always necessary to make good decisions. So I'm going to talk about an example where we made a decision with the knowledge of the field staff. Often they have enough knowledge so we can make those good decisions. This was about hydrant maintenance. The hydrant maintenance staff were doing preventive overhauls of 700 hydrants a year. We have 14,000, so you get an idea, 20-year cycle. And what this graph shows, the first column represents the cost of those overhauls, $180,000 to do 700 hydrants. What they wanted to justify was going from a 20-year cycle to a 5 to 10-year cycle, 7 years. That's what they were interpreting the manufacturer recommendations. So they wanted my help to justify doing 2,000 overhauls a year, which is equivalent to $500,000 worth of work, staff time and equipment. The question was, is this worthwhile to do? We didn't have a lot of data in a database, but we had knowledgeable field staff. So the question became, how many replacements and repairs would we avoid if we did more overhauls? So we talked through all this. We listed all the failure modes that lead to replacement and repairs. We then talked through which of these failures would be avoided if an overhaul had been done. They concluded that none of the replacement failure modes would have been avoided, but 3 of the repair failure modes would have been avoided. And those are the last 3 columns there, values going up representing savings if we were doing these overhauls. Together, we found it really didn't seem to be worth it to increase the amount of hydrant preventive overhauls. They decided to eliminate preventive overhauls altogether, although we still do them as part of repairs or do overhauls when necessary there. So while we had limited data, we had knowledgeable staff, them, and someone to keep track and tally up the benefits and costs of doing more. That was me from the asset management. And the result, while a surprise, was adopted by the very people who thought originally they should do more and then realized maybe they were doing too much. So those are my tips for today, and I'll pass it back.
Great, thank you so much, Jeff. If you guys have questions for Jeff, make sure you type them into the box on your control panel, and we will address those at the end of the workshop. And coming up next is Kevin Campanella. Kevin is currently the utility planning leader for Burgess & Nyepel in Columbus, Ohio. He is a professional engineer with over 20 years of experience in wastewater engineering and utility management. He spent most of 2002 in New Zealand, specializing in asset management, and for over 12 years in Columbus has specialized in asset management implementation, both as a consultant and as the director of Columbus DPU's asset management program. He is also serving as the committee chair for the AWWA Progress in Asset Management Implementation Survey. So bear with me again for just another minute. We're going to switch to Kevin's presentation.
All right, I think I've got control here. So thanks for the introduction, Dawn, and greetings to everybody on the call today. I appreciate the opportunity to share some lessons that I've learned over the years implementing asset management. I'm going to try to keep it relatively simple today. I'll offer some general advice on advancing your asset management work, provide some examples of some specific things that you can do to apply asset management concepts to improve your utility, and then conclude. So getting started and moving forward, the first tip I have, you've seen this before, is to get started. A wise man said when it comes to asset management, the best thing to do is to do something. That was Jeff about 10 minutes ago. From the late great baseball philosopher Yogi Berra, when you come to the fork in the road, take it. What I like about this yogiism is that it represents a dilemma that many small utilities face. There are always a lot of things that could be done, but small utilities don't have the resources to do everything, so they have to choose. The worst thing is to do nothing, maybe out of fear that you would do the wrong thing. Maybe the next worst thing to do is to try to do everything but complete nothing. It's important to do something. There are more tools and technology and data at our disposal to do things more efficiently now. And customers expect that utilities will keep up. You may have sewer inspections on VHS tapes. You might have water main break data as push pins on a map. Now that information can be digitized, it can be analyzed more efficiently to make better investment decisions using asset management concepts. And if your utility is more efficient, it helps keep down costs, which will improve your community's quality of life and support your local economy. So a couple more quotes from Yogi. If you don't know where you're going, you'll wind up somewhere else. And we might be lost, but we're making great time. The point here, of course, is that to get started, you need to have a vision or make a decision about where you want to go. You shouldn't just start for the sake of starting. So tip number 2 is to start with a plan. So I've got 2 young kids that love Dora the Explorer. And in addition to the TV show, I read a lot of Dora storybooks to them, which, if not for the fun the kids are having, would probably get very repetitive because every story follows the same format. Dora is faced with a dilemma that requires that she go somewhere in order to find something or help somebody. It always involves 3 destinations, like over the river and through the woods to grandmother's house we go. And for whatever reason, she never knows how to get there. So every single story has the same 2 lines. Who do we ask for help when we don't know which way to go? Map. Trying to figure out which way to go to advance your asset management in your utility is a lot like a Dora story. You need to first have a plan for where to go. One of the aspects I like about this illustration is that every character is staring at the leader for direction, saying, we just have to know where to go. When you create and communicate the vision for how to advance your infrastructure management practices, your staff can follow the plan, and you'll be pushing in the same direction. Creating a plan can seem like an academic exercise at times, but if you create a simple, practical plan for moving forward, it will generate more results than if you don't have one. So this is an example of the asset management plan for the City of Columbus, DPU, where the formal approach to asset management started in 2008 simply by creating a position for a dedicated asset manager. That was me. Having me develop the plan that you see in this illustration, and then determining what resources I needed. In 2009, we started implementation of only 3 things: determining our service levels, enhancing the computerized maintenance management software, and then not implementing, but just developing our business case evaluation process, which was our way of evaluating alternatives during the preliminary design phase of capital projects. In 2009, we also took part in some benchmarking that we used to even further define our plan to implement asset management. The results being a number of initiatives, some of which were implemented and some of which were held back. This is a simple plan, and admittedly we spent a lot of time on it. Columbus is a big utility where this type of planning is necessary to get a staff of 1,200 moving forward together. But I would say that planning is just as important at small utilities where resources are even more precious. So what goes in your plan? And that leads to tip number 3, which is let your drivers dictate your plan. So if aging infrastructure is your main driver, use the risk-based approach that Jeff described to determine what replacements or rehabilitations to make. If regulations or demands are driving capital projects in the near future for your utility, learn more about how to apply asset management concepts like the quantification of risk or triple bottom line factors to limit project costs and get the most out of your capital budget. If operational costs are rising and becoming problematic, look at optimizing chemicals and energy usage. So use your main driver to figure out what should be in the plan. And then tip number 4 is pick one thing to improve. Do it well and follow it through to completion. The utility will continue to manage all of its drivers, but change just one thing about your major business practices at a time. Start small with pilot efforts. Make your mistakes and address them at a pilot level. Try to get it right with the people who are most affected by those changes, and then implement it more consistently and more globally across the utility. Early mistakes in an asset management implementation can be discouraging, and they can even doom the change. So limit them so that they don't cause too much harm and you don't get too much pushback. And be patient with others. You're not just changing what they do, but you're changing how your utility does things, and that can take a long time. Okay, so that wraps up the more general advice and tips. I'd like to talk about some specific things that you can do to advance asset management practices. So tip number 5, if cost is the driver, follow the money. And what I mean by that is look at optimizing your operations. If your utility operates a treatment facility, the largest operational costs are chemicals and energy. Almost all treatment plant energy costs are going to be in pumping water or blowing air. At Columbus Public Utilities, treatment plants use 55% of all the power consumed by city government. I'm not sure about the stat for blowing air. There's a joke in there somewhere. But look for efficiencies with chemicals and energy to help reduce costs. It can be done. For example, here's a water treatment example. If you traditionally backwash filters for 15 minutes, and to reduce operational costs, you consider backwashing for only 12 minutes. You can save money, but you can also introduce some risks. Using an asset management approach, the additional risk can be evaluated with data, and you can weigh that risk against the cost savings. This was the case at a water plant in Columbus where the time between backwashes was increased and the actual time of backwashing was decreased, resulting in a savings of $50,000 per year. And those changes were supported by data on filter performance and backwash effectiveness. Likewise, in Columbus, we looked at one of our drinking water plants where water is softened, and they have a total hardness goal of between 120 and 125 milligrams per liter of hardness in the finished water. The plant was operating on the conservative end of that range, taking hardness down to an unwritten target of 121 milligrams per liter with a great deal of precision. Because we were able to use data to demonstrate precise control, operators felt a lot more comfortable making the switch to the less conservative end of that range, applying less softening chemicals and achieving a chemical savings of $60,000 per year. Keep in mind that hardness is not regulated. Too much hardness in finished water can cause a buildup of scale on electric heating elements and boilers. It can even stain laundry, but overall the utility was not assuming a great deal of risk by operating closer to the 125 milligrams per liter of hardness goal in the finished water. Okay, let's move on to the topic of maintenance. And tip number 6 is get the most from the assets that you have. It doesn't mean that you have to preserve assets at all costs. And there are some assets where running them to failure is the most cost-effective strategy. This is about preserving the investments that you make into assets and managing risk. So, like Jeff said, you want to focus your maintenance efforts on high-risk assets. Repairs, replacements, and expansions are costly. If you have to add capacity in the form of redundancy because your existing assets are not reliable, you'll have to maintain more assets. Another reason to properly maintain assets is expected levels of service required by regulatory bodies. Sewer capacity needs to be maintained because of the clampdown on sewer overflows. Wastewater plants have to be reliable because the same applies to plant bypasses. So if you can achieve a high level of reliability in your systems through proper maintenance, you can reduce the amount of capital investment necessary to meet your goals. So here are some tips that are focused mainly on facility-based assets. First, mechanical assets tend to be over-maintained based on manufacturers' recommendations designed to get an asset through the warranty period. So try to find the time to review your maintenance program on assets after the warranty period is over and see if the maintenance is justified. You may be able to eliminate some tasks or reduce their frequencies in order to free up some time to maintain other assets. On top of that, studies have shown that the emergence of most asset failures can't be predicted. They happen at random. So a lot of traditional preventive maintenance outside of changing oil and filters on traditional wear and tear assets is not always effective. Predictive maintenance devices, which are becoming more and more affordable now, can help you detect the defects that lead to failures so you can address them prior to a more significant failure. It takes an investment and some training, and you have to maintain the predictive devices like ultrasonic or vibration equipment. So this may not be for every utility, but experience has shown that the return on investment for predictive maintenance can be very, very high, and so it's worth investigating. If you look at the time that you spend on maintaining assets, about 2/3 of it should be on proactive work and 1/3 on reactive. And of that proactive work, you really want to have an even mix of predictive maintenance versus preventive. In addition, the last bullet on this slide involves safety risks. Think about a chemical storage tank that's being filled. When it reaches a certain level, a high-level alarm will activate. If that alarm were to fail, typically there's a higher alarm called a high-high alarm, and that would activate before the tank overfills. So the question is, if the first high alarm always works, how do you know if the high-high alarm is working? The only way to truly check is to fill the tank past the first alarm, under controlled circumstances, of course, but to see if that high-high alarm works. And sometimes these types of safety checks are overlooked Clearly, they need to be considered. This slide shows some of the benefits that will be achieved through optimizing maintenance practices, including some results from Columbus, some pilots that we ran. We were able to reduce PMs that weren't warranted. We've, again, added PMs that were missing, a lot of them around safety. And you can achieve a great deal of savings through predictive maintenance, finding defects before they become major problems. And the result, overall result, is a more reliable, more cost-effective, and safer facility. So summarizing tips on maintenance, try to swing the balance to be more on the proactive side of maintenance versus reactive. Focus on high-risk assets. Look at your maintenance activities with that in mind, and stop checking the same piece of equipment monthly if it hasn't failed in 3 years, and the consequence would not be that great if it did. Look at your assets that are failing frequently to see if there's anything you could be doing to either predict it or prevent it in order to limit the impact. Okay, moving now to capital investments. The second to last tip of the day is that the best opportunity to avoid costs on a capital project is early in the design. You don't have too many opportunities to avoid costs at the 90% construction phase, particularly if you chose the wrong approach to the project to begin with. Taking the time in the conceptual and preliminary design phases to make sure you look at various alternatives and go beyond the obvious solution will help you reduce the cost of capital projects. I'd like to illustrate that with a story. This map represents the area served by Columbus's water treatment plants. The pink shaded area represents the area served by the Hapcremene water plant, and it's an area that's seen extensive development over the last 25 years. This has put a lot of pressure on the water distribution assets in that area. Pumping stations use all pumps with little to no redundancy on the hottest days of the year, keeping pressures in the system high, which doesn't allow the water in elevated storage tanks to turn over frequently. And in some cases, the city has to dip into storage that is meant for emergencies just to meet peak demands during non-emergency situations. Now, many years ago, a solution was proposed and quickly adopted. It was a solution that would solve all of those growth issues by serving some parts of that northwest distribution system with water from another treatment plant. It involved a new booster station and 10 miles of transmission main to the tune of about $26 million. If not for the fact that land could not be acquired for the necessary booster station, the project would have moved forward. A second solution was quickly adopted, involving 5 miles of new transmission main and a river crossing within the study area, with a reduced price tag of $17 million. And like the first solution, it was a good one. It addressed the risks that faced the area, but like the first, not all of the necessary easements could be obtained. So a third solution was proposed, but this time it was studied in a lot more depth using the business case evaluation process that I alluded to before. It involved only a mile of transmission main and a river crossing with a total cost of $8 million. And in the process of studying this change, it was determined that by simply increasing system pressures, by providing some redundancy at booster stations, and turning over water in elevated storage tanks with jockey pumps, that no transmission mains were needed at all, and the overall cost of the project was only $4 million. So again, if one piece of land could have been acquired, the $26 million option would have gone forward. So the moral of the story comes from the late John Wooden, who said, if you don't have time to do it right the first time, when will you have time to do it again? Take the time at the beginning of a project. Don't lock into a solution too soon. Examine alternative solutions and use some asset management approaches to try to determine which project alternative gives you the most value for your investment, even if you don't address every last bit of risk on the project. So just to wrap up, get started. Do something this year, even if that is just getting a plan to move forward together. Use your most pressing drivers to determine what one thing in your plan to implement first. And do that one thing well and follow it through to completion, whether it's capital, operations, or maintenance focused. And I promise one last tip, and that's to steal whatever you can from others to help you move forward. We didn't have a lot of time to get into details today, but there's a lot of information available to you, much of it through the Environmental Finance Center Network, professional organizations, and even other industries that involve the management of large infrastructure systems. A lot of utilities and consultants have been active in supporting asset management change over the last decade and have published a lot of information on different approaches. So look around, and you're bound to find some useful information on how to implement whatever it is you decide to get started on.
Thank you, Kevin. If you guys have questions for Kevin, feel free to type them in now. And I am going to switch things over. Brad, can you switch it and I will stop?
Yes, I'm switching it right now.
Thank you.
Okay, can you see my screen?
Yes.
Okay. All right, this is Paul Crocker, and I want to thank you guys for listening to the other two presenters. They had great material, and I'm going to follow it up with some about 15 minutes of practical stuff. I do have two videos that probably won't work, so when I get to them, I may have to switch gears on how I present those, but be patient, and when this is over with, I'll re-record this and put it on a YouTube video and send it back to Don to forward to everybody. So let me get to my first slide.
Well, I didn't get a chance to introduce you, so if you'll give me just a second,
Oh, sure.
Introduce who you are, and then I'll let you take back over again, okay?
All right.
So Paul is a 23-year employee with the Kansas City Board of Public Utilities in Kansas City, Kansas. For the past 7 years, he has been employed as supervisor of maintenance at Nearman Water Plant, which is a drinking water processing plant. During that time, he went through the AMCAN work program with Heather as the facilitator, and he has applied the lessons that he learned through that program to apply for and receive a full 10 points from the Kansas Public Water Supply Loan Fund for guaranteed loans for low-cost loans for the utility. Paul is working to start a Kansas City-based chapter of Society for Maintenance and Reliability Professionals and is planning to take the CMRP exam within the coming year. Paul is a water supply system operator class 4, and Paul is married for 26 years with 2 sons and 1 daughter, and he has an AKC boxer named HX. So take it away, Paul.
All right, thank you, Don. All right, let me get into my first slide here. So the agenda of what I'm going to cover is asset lifecycle, linear assets, vertical assets, asset data, where to get that data, locations, dabble a little bit in parent-child relationships, strategic spares, and at the very end, resources to help you grow and know. And note that this is really what I'm going to talk about is in the sphere of asset management. It's in the work execution management area, and this is really going to go towards collecting data necessary to populate a CMMS system or computerized maintenance management system. This will also be working at the operate, modify, maintain, and disposal end of the asset management life cycle. And that's okay if this is where you're starting at. That's where a lot of people start at, and it's always a work in progress, and you got to start somewhere. So this is a great place to start. So the asset management life cycle, business usually starts business needs analysis, strategic asset management plan, design, build, operate, maintain, modify, upgrade, and dispose. And part of that really goes to part of the business needs analysis. You need to know what the mission or aim of your organization is, because fulfillment of that mission or aim should guide all of your decisions related to asset management. For instance, at BPU, our mission is to focus on the needs of our customers to improve the quality of life in our community while promoting safe, reliable, and sustainable utilities. Linear assets, main stormwater, sanitary, drinking water, reservoirs, power distribution, aerial, buried, transformers, substations, poles, roadways. I really won't talk too much at all about linear assets because I don't deal with them day to day. That said, they have hierarchies, systems, and many of them have the same properties as vertical assets do, but it's just that linear assets stretch across distances, blocks, streets, cities, counties, states, etc., which makes them a unique type of asset. And often the case with utilities such as power, water, and wastewater, those assets are generally hard to access. Vertical assets, by comparison, pumps, motors, gearboxes, valves, motor control centers, compressors, there can be as much or little granularity or details as you like when you collect this information. Again, think about your company's mission, aim. Ask yourself if going to the level of granularity that you really want will help fulfill your company's mission or aim or not. In my experience, a little more is better, but you should definitely define a place to stop for whatever asset class you're looking at. And know at the end that this is your data and you're the one who'll be using it. You know, for instance, you might use very coarse detail, simply call an asset like a aqua ammonia metering pump, just that, and then that covers everything in the pump, the motor, pump, heads, gears, valves. And if a work order or something is written against it, it's just simply written against that asset, aqua ammonia metering pump. But you could also make it very detailed and break those components down to sub-assemblies, which is what we do here, and then use the parent asset tag as part of those sub-assemblies, like ammonia metering pump 1, head 1, or pump 1, or gear 1. That way you can go back later on and find out where your failures are and address those better. Asset data, tools you need to collect the data, pen, pencil, paper, clipboard, and a warm body. Access to a facility where the data or where the information's at. And with just those items, you can begin your journey to asset management. You also, at some point, need a desktop computer with Microsoft Excel or an Access database. And this below are some options or modifiers, nice stuff to have if you didn't want to use pen and paper. Also, you could use a laptop computer, a tablet PC, and a digital camera is nice to have too if you want to record a video or visual portion in your asset data. Where to get the data, locations. Here's a physical asset sites, company, facility, building, floor, room. At the asset, at a minimum, you want to collect the manufacturer, vendor, model, serial number, equipment description. The engineering specification, you want to get a contract information, spec section number if the equipment is built with the design spec. Engineering drawings, you want to get an engineering set information, or drawing set information, drawing set number, P&ID data, tag number, which in our case was used to create the unique asset number. Examples of what this looks like. So ammonia metering pump 3, what it looks like, and a handful of data collected, data transcribed to Excel, and finally what it looks like when it was all put together. So we've got an ammonia metering pump here. I had the original documents that they collected the data when the plant was new, and we're just going to walk through collecting that data and then how it eventually looks in the CMMS. So this next slide is a video, and I hope it works good enough. If it doesn't, I apologize. I'll try and work through it here. This is the control panel for and that's what I thought would happen. So this is the control panel, and the mouse is pointing at the asset tag, aqua ammonia metering pump 3 control panel. And it in of itself is a parent asset to 2 child assets that sit to the left and right of it. To the left of it is a control for one head, an SCR, and it would be asset AAMP 3 SCU1, and the one to the right of it is AAMP3 SCU2. And throughout our plant, we've used these phenolic tags with orange background to describe what asset we're working on. The back half of this is the actual pump itself: pulsation dampeners, tach generator, motor, heads, back pressure regulators, gauges, the pump, dual simplex pump itself, and head 1 and head 2 that correspond to the control units on the front control panel. And all those are subcomponents of that whole aqua ammonia metering pump. We also have some little black tags that you can see hanging around that the mouse is pointing to. And those are part of our risk management plan, valves that we maintain and sequence of operation when opening and closing them. And all that data is contained in a one-line diagram on the chart behind where this pump sits. So an operator can look at the chart and know which valves to open and close for different scenarios. So this is one of the original documents we used to populate our CMMS. It is was an Excel spreadsheet, and it probably took a year total to go through it. And when it was all completed, someone would come back and verify the information on it was correct. So in my example here, aqua ammonia metering pump 3, you can see an equipment ID. You can see that this is Nerman Water Treatment Plant. The sublocation of the plant is chemical feed, or the location is chemical feed, and then the sublocation is ammonia chemical feed. And these are maintenance points or assets. So aqua ammonia metering pump 3, you can see the definition that we gave it. The original manufacturer, U.S. Filter Wallace and Tiernan. Model number, an Encore 744 series, serial number. The original vendor, which was Haynes Equipment, and that vendor got changed out, so we don't use that particular vendor anymore. And spec number and O&M information are all on that. I'm going to try and advance my video here just a little bit. So I'm going to log into my CMMS here. We use Maximo, but there's lots of other variations of this. You definitely don't have to use a Maximo to do asset management for your CMMS. So I'm going to change to my aqua ammonia metering pump, the asset tag AAMP3, and it will show me the tag that we had on the previous Excel spreadsheet, AAMP3. It will show the description, aqua ammonia metering pump 3. It will also show us that we're the owner water production at site BPU. Operating status is it's operating. It's located in ammonia chemical feed. We have the serial number from the Excel spreadsheet. We have a regulatory box to check, and install date, which was 5/1 of 2000. That's when the plant came online. And I just went ahead and populated this so you can see something being added to CMMS and how incredibly hard it really isn't. And then there's also an asset priority, which I can click and tell it it's critical, essential with backup. We have another pump that's just like it. I see the original vendors, or vendor's been updated to Cyber Environmental, the manufacturer, U.S. filter, the installation date. At the time, because it was a contract, the purchase price and replacement cost wasn't recorded, but year to date, or total cost for that asset is somewhere around $10,000 over the last 15 years. We have a spec number off the original Excel file, mechanical construction drawing information, and O&M book. And part of that O&M book is within this application. Any of those fields can be double-clicked and launched an application called OnBase, which is our document management system. And that document management system will return with the drawing or the contract or the O&M manual, so you don't have to go hunt down the drawing. It'll just return that information to the screen for you. And I'm not going to go through that because it would take a lot longer to launch and show. So one of the last piece of this is the spares. For that particular asset, it does show the sub-assemblies, the control panel, the gearbox, head 1 and 2, and it also shows the spare parts that go along with that asset. We have some meters that we control runtime hours with. If I want to view work to see what we've done in the past, I can turn on the history flag, and until I want to look for work orders that are in the status of closed. And then I can see all the work orders have been generated against that asset since our CMMS went online. And then all the cost of those work orders is rolled up back to the asset screen in that total $9,000 operating cost. So you can eventually, if you need to, make decisions on whether to keep maintaining that pump or to replace it. Okay. This next section is resources to help you know and grow more about asset management. And I had another little video here which I'll talk through. This is ESCN's webpage. It's a very nice and focused set of resources geared specifically to utilities. And I wanted to show you just a moment the website itself and let you know that you should definitely bookmark some resources on this page. So once you're on the web page, it'll go through some graphics, but go to resources and down to tools. And on this tools section, you can see all the different tools that EFCN has that are available for your use. Introduction to Energy Star Portfolio Manager Tool, AMIQ, which we use here, rates and financial dashboard for some different utilities, user-friendly capital improvement plan tool, EPA energy use assessment tool for drinking water systems, water and sewer rate analysis sheet, a checkout program for small systems, that's a CMMS, a dashboard for using capital reserve fund to avoid shock, 25 questions for assessing your water utilities financial system, an asset inventory database, asset management handbook for small systems, subsidizing funding benefits calculator, loan analysis tool, climate ready water utilities toolbox, revolving fund model. So the website itself has a lot of great tools, and it's definitely one that you should benchmark or bookmark. Other resources, and I'll email these out. There's no reason to write them down. The Environmental Center Network, the Tools section, the Institute of Asset Management. They've got a nice little video called The Big Picture on asset management. It's definitely worth the time to watch. SMRP, the Society for Maintenance and Reliability Professionals. The Association for Asset Management Professionals, AMP. And there's many more, and I'll compile all these together and send it out at the when this webcast is over with. And that's all I have.
If you guys have any questions, feel free to type them in now. While you're thinking about your questions, we have a couple of poll questions for you to answer about further assistance and interest to you. So if you can take a look at your screen, and Brad, if you can start the first poll question.
Yep, okay, so just launching the first one now. Would you like to subscribe to the UNC Environmental Finance Center blog? And we'll give you about 20 seconds to answer this one. Okay, thank you for all that responded. And now for the second question. Are you interested in receiving in-depth technical assistance for your small water system? So as the Environmental Finance Center network, we have the capability of providing your system with up to 20 hours of technical assistance on the topics that I mentioned before in the introduction: asset management, water loss reduction, water system collaboration, fiscal planning and rate setting, energy management, funding coordination, and managerial and financial leadership. So if you indicate yes, we will follow up with you at a near date. Okay, and thank you for everyone who responded to this question.
All right, well, I think that we have reached our end time, so thank you all for attending today, and if you have any questions, feel free to let us know. We'd be happy to answer them for you. We will send out a survey to your email at the conclusion of this webinar, so we would really appreciate your feedback. And thank you all again for your attendance.